We begin by simplifying the expression x squared y to the 7th over z to the 5th, all raised to the 1/3. And I note that this is the way it looks when we type it. This is the way it looks when we do it in linear notation with fractional exponents. With radicals, it looks like the cube root of x squared y to the 7th over z to the 5th, because we know that the cube root is the 1/3 power. Going into this form, and I think it's good to be able to go from this form to this form because the laws of exponents apply in a much more obvious manner. So we distribute the 1/3 power over all these multiplied and divided quantities, and we get x squared to the 1/3, y to the 7th to the 1/3, z to the 5th to the 1/3. And this is, of course, then x to the 2/3 times y to the 7/3 divided by z to the 5/3, multiplying exponents. A power of a power, we multiply exponents. If you have x squared cubed, you have x squared times x squared times x squared. That's x times x times x times x times x times x. There's 6 of them. It's x to the 6th. You multiply the exponents. You always need to be able to think about that. Okay, so x to the 2/3 is going to remain as it is. But with y to the 7/3, I'm going to write that as y to the 6/3 times y to the 1/3. Because, of course, 7/3 is 6/3 plus 1/3. And when we multiply, we add exponents, again, for a reason that's very clear if you think about what it really means. Why do we do this? It's because y to the 6/3 is going to be a y to an integer power, to a whole number power. Okay, so we have y to an integer power here times y to the 1/3. So we're basically factoring out an integer power of y from y to the 7/3. And with z, we do the same thing. We have z to the 5/3. We can write that as z to the 3/3 times z to the 2/3. Now, y to the 6/3 is y squared. Z to the 3/2 is z to the 1, or just z. And the rest of our factors are either a 1/3 or a 2/3 power. So there are no further integer powers that can be factored out. And now we can write this as y squared over z, z to the 1, of course, being z. And then x to the 2/3, y to the 1/3 over z to the 2/3 can be written as the 1/3 power of x squared times y over z squared, or the cube root of x squared y over z squared. And I've got an intermediate step here as well. If we don't want to go directly from here to here, x to the 2/3 means the cube root of x squared, y to the 1/3 means the cube root of y, z to the 2/3 means the cube root of z squared. And now we have cube roots of this, this, and this. We can just put them all under one cube root sign, since these are all multiplications and divisions. So we have the cube root of x squared y over z squared.